Welcome again, dear grade 9 students, and we are going to continue about radicals. Some ideas you already knew from grade 8, and some ideas are totally new and you are going to be familiar with it by the end of this video. Properties of radicals. First of all, we keep on saying that a and b are positive real numbers whenever we put a and b under the radical sign, because as I told you previously that the radical sign cannot include a negative number inside, or it is undefined in R. R is the set of all real numbers that you can talk about. So radical a times b is equal to radical a times radical b, as if I'm saying that I can split the radical if there is a multiplication sign separating a and b, or the values inside the radical. Similarly, if the values are separated by a division or they are written as a fraction, then I can split the radical and I can separate them as well. Here the condition under b is that b is not going to be 0, is prevented from being 0 because it's in the denominator. And here are examples, and as I told you previously, whenever I'm going to find the value of a radical, the exact value of a radical, I have to decompose the number, the positive number inside the radical, into product of powers of prime numbers, as you see here. So radical 48, when I prime factorize 48, I'm going to get 2 power 4 times 3, or it is 16 times 3, and 16 is 2 power 4. Let's make a little revision for the prime decomposition. This is how to prime decompose 48. It is divisible by 3. The answer is 16. It is divisible, 16 is divisible by 2, and the answer is 8. 8 is divisible by 2, and the answer is 4. 4 is divisible by 2, the answer is 2. And finally 2 is divisible by 2, and the answer is 1. And we stop when the final number is 1. So we have 2 to the power 4 times 3. So if you didn't get it, that 48 is 16 times 3, all what you can do is to simplify. New calculators will give you radical 48 directly like this. So if you don't have a calculator, or calculator is prevented, all what you can do is to prime decompose the number inside the radical. So we will get radical 2 to the power 4 times 3. Now the radical 2 to the power 4 and radical 3 can be separated because there is a multiplication sign in between them. Radical 2 to the power 4 is going to be 2 to the power 2. Where did this come from? Here is an important remark to recall something you knew from grade 8, that radical a to the power n is exactly equal to a power n divided by 2. So we divide the power inside by 2. Radical a squared is the same as radical a all of it squared, it is a. And radical a cubed is a radical a, because radical a cubed is going to be separated into radical a squared times a. A squared will be put outside the radical as a, and radical a will be kept inside, and a will be kept inside the radical. So this is how to decompose. This is a brief revision how to decompose radicals and how to get out radicals and to get powers out of radicals. Let's continue with, as well as radical 6 times radical 3. If the radicals are separated, I can put them under the same radical and find their product. So it's radical 18. Now I can decompose 18 as I taught you just right now. Radical 18 is 3 squared, radical 3 squared times 2. Now 3 squared can be taken outside as 3, because radical of a squared is a, as you see here. So radical of 3 squared is 3, and 2 is kept inside the radical. Similarly for this one, radical 15 over radical 35 can be put under the same radical. I can simplify, or I can decompose. 5 times 3 is 15, and 5 times 7 is 35. Now I can cancel 5 with 5 to get I can cancel 5, simplify 5 with 5 to get radical 3 over 7. So this is a brief summary or a brief revision how to simplify radicals in case I have multiplication or division. Now a number, here is an important remark. A number is said to be a perfect square. So this is an important idea if it can be decomposed as a product of even powers of prime numbers. What does that mean? For example, this number radical 225, if you find radical 225 on the calculator, you definitely get the answer. So radical of 225 on the calculator is given as 15. Radical 144 will be 12. Radical of this will be 14, and so on. So how to know if a number under the radical is a perfect square? That means its answer will be just a natural number without decimals. So the perfect square is a number whose radical gives a natural number and not a decimal without any decimal point. So radical of 225 will be radical of 3 squared times 5 squared. Now 3 squared will be taken outside as 3, and 5 squared will be taken outside as 5, and the answer will be 15 as the calculator will give us. So to know if a number is a perfect square or not, all what we have to do is to prime decompose it, as I taught you here for 48. You prime decompose it, and if the result is a product of prime factors with even powers, as you see here, the powers of the prime numbers or the prime factors are even, which are 2, 4, 6, 8, etc., then I can say that this number is a perfect square, and when I make the radical for this number, I will get definitely a natural number without a decimal point. Let's continue to see what we have in this slide. Here are more examples on simplifying radicals. For example, if I have 2 radical 45, I can keep 2 outside. All what I do is to decompose 45 into 9 times 5, which is 3 squared times 5. Now 3 squared is going to be taken outside as 3, and this is the best way of writing in order not to forget. So 2 times 3, I multiply these numbers, I will get 6, and 5 is kept inside the radical. Minus 3 radical 125. Minus 3 is kept outside. 125 is 5 cubed, so it is 5 squared times 5. The number with the even power, I divide this power by 2, so I will get 5 outside, and thus I multiply minus 3 times 5, I will get minus 15 into radical 5, and 5 is kept inside the radical. 5 radical 112. 5 is kept outside again, and 112 is decomposed into 2 power 4 times 7. So 2 power 4 will be taken outside as 2 power 2. We divide the power by 2, and then I will get 5 times 2 squared, which is 5 times 4, which is 20 as well, and 7 is kept inside the radical, and the final answer is 20 radical 7. So these are simple examples on how to simplify radicals, and we are going to see more and more examples within the training exercise later.